This is Geometry, Chapter 10, the first lesson. It's on page 378. So we're starting a new topic. And the topic is similar polygons or similar drawings. All right. Now, what we've done so far is shapes or items that are congruent. And when they are congruent, they have the exact same angles, corresponding angles, and the exact same corresponding sides. So that each angle from both shapes has a corresponding and equal angle, and each side from each shape, from one shape, has an equal and corresponding length of a side from the other shape. That is not so with similar polygons. With similar polygons, our angles are all going to have an equal corresponding angle. So the angles, all the angles are going to be equal and corresponding, but the sides are not going to be. The sides are going to be proportional. All right, so if I had an equilateral triangle, right? We know that the measure of each angle of an equilateral triangle is 60 degrees. And let's suppose I had another equilateral triangle. I could know that all the angles are equal. I'm gonna call this A prime, B prime, C prime. All of the angles are equal. Angle A is congruent to angle A prime, B to B prime, C to C prime. But if I'm looking at the sides are going to be proportionate. There's some ratio or scale factor that I can multiply it by to get to this other one. All right, so this is very much what we use with parallel lines. So look, if I take A times some scale factor, I can get to A prime. All right, so I'm going to tie this into parallel lines. All right. If I have parallel lines, I'm just going to say 3 sets of parallel lines. And I have 2 transversals. We'll have 2 transversals. All right. So we'll name our parallel lines L, M, and N. We know that our corresponding angles are equal, right? Those are our corresponding angles. Because we have the angles that are equal, our lengths are going to be proportionate. So this is what we're going to do when it's what it's going to look like in algebra. If this were length A, I could multiply it by some scale factor to get to A prime. All right. So this concept ties very closely in to parallel lines. All right, so let me just give you an example here. And there's a very important concept at the very end of this video that I will use from here through pre-calculus, all right? All right, now I'm not gonna make a equilateral triangle. I'm gonna say these sides are 3, 6, and 8. That's what I should have said 2, huh? Let's make them all even. 2, 6, and 8. Doesn't look like it. Let me draw it like it looks like it, right? All right, so if that one is 2, this one is 6, and that one will be 8. And we'll say angle A has to be the biggest angle because it's opposite the largest side, and the sum of them has to be 180, right? So we'll make this 80 degrees. We'll make this let's make it 30 degrees and we'll make that 70 degrees. Okay, let's suppose I have a bigger triangle, but I know that the angles are equal. We'll call that A prime, B prime, C prime. And let's suppose the length of this side is 6. And this will be B prime, this will be A prime, all right? So now all of our angles are congruent. So angle A is congruent to angle A prime, B congruent to B prime, C congruent to C prime. Because I have all the angles equal, I have similar triangles. All right, so triangle ABC is similar to triangle A prime, B prime, C prime. All right, they're similar. Similar means all of the angles are equal. But now my sides are not equal, but they have corresponding sides. All right, and the corresponding sides go between the equal angles. So this side AB corresponds to A prime, B prime. This side AC corresponds to this B prime side, A prime to C prime. This side labeled ABC corresponds to B prime, C prime. So if I found a scale factor, if I said 2 times some scale factor equals 6, then I could multiply 8 by that scale factor and get the A prime. I can multiply 6 by that scale factor and get the B prime. Or I could use proportions. All right, so I can use a scale factor. And this idea, this concept is used in so many different industries. Architecture, modeling, in your arts, when you are sketching a live object, you're probably scaling it down. Your scale factor, you're scaling it down to a smaller drawing to place it on your artwork, right? So it is used a lot, right, in many industries. So we can use scale factors or we can use proportions. All right, so I like to write it like this. In the smaller triangle on the left, we have 2, 6, and 8. In the larger triangle on the right, and I write the corresponding sides. So 2 corresponds to 6. We got to go to 6. 6 corresponds to B prime. 8 corresponds to A prime. Now, if I see an obvious scale factor, I'm going to work this 2 different ways. Then I use it. I know that if I multiply 2 by 3, I get 6, right? So 3 is my scale factor. So if I multiply 6 by that same value to get to that scale factor, to get to that the length on my similar triangle. So the value of B is going to be 18. Also, I can multiply 8 by 3 to get to my A prime value, and that would be 24. And I would have solved for B prime and A prime. Or I can use proportions. All right, so I'm going to go back. You can use your scale factor if it's an obvious scale factor. If it's not an obvious scale factor, so I'm going to change this from 6. That was an obvious scale factor. And now we'll change that to 5. Let's suppose that that side is now 5. So now we have 5, B prime, A prime. Now the scale factor is not obvious. So I'm going to use proportions. All right. So as you can see, I've injured my wrist. I'm going to write ratios. I'm always going to use the 2 values that are given. All right. So I'm going to write ratio. I'm going to say 2 over 6 equals 5 over B prime. All right. 2 over 6 equals 5 over B prime. And once I have a ratio equaling a ratio, this is the only time that you can use this. When you have a ratio, an equal sign, and a ratio on the other side of the equal sign, then you can use cross multiplication. That's the only time you can use cross multiplication. A ratio equals a ratio, or a fraction equals a fraction. Then you use cross multiplication. So that's 2 times b. My equal sign stays. Equals 30. I divide by 2. That's b prime. B prime is 15. Wasn't necessarily expecting a nice even value, but I have it, right? Now, to solve for a prime, I'm never going to use a number that I've calculated, because if I've miscalculated the b prime value, if I've made a multiplication or division error, then when I use it to calculate a prime, I'm going to have another error. I'm going to have 2 wrong solutions. So when I'm calculating a prime, I'm going to ignore the middle. And I'm going to say 2, let me just, I'm going to ignore the middle, right? I'm going to say 2 over 8 equals 5 over a prime. So 2 is to 8 as 5 is to a prime. And again, because I have a ratio equaling a ratio, I can cross multiply. So that's 2a prime equals 40. I divide both sides by 2. A prime is 20. All right, I can use that cross multiplication. All right. Now, I'm going to go back to this 2 over 8. And I'm going to go ahead equals 5 over 20. So we can talk about what these values are. All right. This 2 and this 8, when we cross multiply, that is called, these 2 values are called my extremes. All right. And the 5 and the 8, they're referred to as my means. All right, so this is the concept that is on page 380. All right. It says that the geometric mean, B is the geometric mean between A and C. Okay, so then I'm going to rewrite this. It's going to be A over B. A over B equals B over C. So B is the geometric mean of my extremes A and C. What does that say? Look, if I cross multiply, let's cross multiply. So my means are the B, right? My extremes are the AC. If I cross multiply, I have B squared equals A times C. When I take the square root, B is equal to the square root of A times C. So B here is my geometric mean. So when we're asking for the geometric mean, it is the square root of the product of your extremes. It is, the geometric mean is equal to the square root of the product of your extremes. All right, this is going to be a very important concept as we move forward, because I can swap my extremes. All right, so if I have 2 equals 8 over x, okay, if I have 2 equals 8 over x, this is really 2 over 1, right? So 1 and 8, 1 times 8, those are my means. 2 and x are my extremes. This is how we're going to use this. So 2 and x are my extremes. I can swap my extremes. I can move the x in the 2 position. I can move the 2 in the x position. So I have x equals 8 divided by 2. See how I just swapped them to solve easily for that. We're going to use that with trig to be able to swap our extremes. So that is always true. You can swap your extremes. You can swap your means. So what I had 2 over 8 equals 5 over 20. 2 and 20 are my extremes. 8 and 5 are my means. I can swap them. I can say 20 over, I'm swapping them, 5 equals, I'm going to swap the 8 and 5, 8 over 2. See, I swapped them. Is that true? That's 4. That's 4. You can swap your extremes and your means because of that cross multiplication concept, okay? But what we're going to do in the future is we're only going to have our mean here is going to be 1. So we're going to be able just to swap our extremes to solve when the variable is in the denominator on that ratio.